Hello, yes, welcome to JSM. In this session, I am going to explain imperfections in solids or crystal defects. So basically, we know that according to Nernst law or whatever the third law of thermodynamics, true crystals can possess only at 0 Kelvin. That means we can expect that a perfect order of arrangement in a crystal exactly at absolute 0 Kelvin only we can expect. But there are some deviations are going to take place in that perfect order of arrangement with increase in temperature. Okay, so that's why there are going to imperfections are going to take place. Okay, when we are increasing the temperature, and also we can expect some defects by the presence of impurities. Okay, so here we are observing that while increasing the temperature and by the presence of impurities, there is some deviation is going to taking place in the perfect order of arrangement. So that's why here I am defining that crystal defect is nothing but any departure from perfect order of arrangement of atoms or ions in a crystal is usually called as imperfection or crystal defect. Okay, so what is that? We are giving the crystal defect. So crystal defect means any departure from perfect order of arrangement of atoms or ions in a crystal is called as crystal defect. Okay, so any departure from perfect order of arrangement of atoms or ions in a crystal, I'm calling that a crystal defect or imperfection. So basically, there are three different type of crystal defects we have here. Okay, so here I would like to give that some classification that all the crystal defects I am going to classify in majorly in three different one. So one is we have that electronic imperfections. Electronic imperfections. Second one is atomic or point defects. Atomic or point defects. And third, line or dislocation. The third one is line or dislocation defect. Okay, so initially I classified that crystal defects in three ways. One is electronic imperfection, second one is atomic or point, the third one is line or dislocation. So majorly most of the solids, okay, so there are atomic point defects usually occurs. So here these atomic or point defects again three types. Okay, one is stoichiometric defects. Okay, here I classifying that atomic or point defects again usually three types: stoichiometric defects. Second one is non-stoichiometric defects. Non-stoichiometric defects, and third one is impurity defects. Okay, impurity defects. So three different type of defects we are expecting from that atomic or point. One is I am taking that stoichiometric defects, and second one is that non-stoichiometric defects, and third one is impurity defects. Okay, so basically here the stoichiometric are again four types. One is vacancy defect. The second one is interstitial defects, third one is Schottky defects, and fourth one is Frankel defects. Okay, so here the stoichiometric defects are again four types: vacancy defect, interstitial defect, Schottky defect, and Frankel defect. Generally here, the vacancy and interstitial defects, usually these are shown by the non-ionic solids. Okay, so these two defects majorly we are observing in non-ionic solids, but whereas the Schottky and Frankel defects usually we are observing in ionic solids. Okay, so stoichiometric defects again four types: vacancy and interstitial, which are shown by the non-ionic solids, and Schottky and Frankel defects, which are shown by the ionic solids. Okay, so at the same time here the non-stoichiometric defects are again two types. One is metal excess defect, okay, and the second one is metal deficiency defect. Metal excess defect and metal deficiency defect. So this metal excess either by presence of, okay, by the presence of anion vacancy, by the presence of anion vacancy, okay, generally these are called as F centers, or by the presence of extra cation, by the presence of extra cation. Okay, so either by the presence of anion vacancy or by the presence of extra cation, it is showing that metal excess defect. Okay, so generally the non-stoichiometric defects are two types. One is metal excess, one more is a metal deficiency. So metal excess defect either by the presence of anion vacancy or by the presence of extra cation. And like that, when you are looking at impurity defects, the impurities may be present in covalent solids or ionic solids. Okay, so this is that basically the different type of defects which are shown by the crystals. Clear?